Question 7, Part 2. Now you're asked to solve this definite integral with limits, alright, and the square of the function f of x. So to begin, what we can do is to at least replace f of x with this function, and then rewrite it out. And you realize that we are actually required to integrate the square of this trigo expression. So the way to do it is perhaps you need to think about rewriting the expression, you need to perform expansion, so that we can make it into a form that can be integrated. So henceforth, our next step is to expand. Alright, so after you expand the terms, what you will get is sine squared expressions, as well as the product of two sine function right here. Now, if you're asked to integrate this, do you realize that actually we have done this similar integration here? And this is our answer. Okay, so somehow we can use part 1 answer. We need to redo the entire thing all over again. So what I will do is now to write into two types of integral. So split the integral up into two integrals. So one integral is for the square of sine. The other one is the integral for the product of the function over there. And I factorize out the two so that I hope you can see that this whole integral right here will result in this outcome. Now, well, you can do that for the second integral over there. For the first integral, the only way to do it is actually to rewrite the expression using double angle. And double angle says cosine 2a is equal to 1 minus 2 sine square a. Henceforth, what is sine square a? 1 minus cosine 2a divided by 2. So rewrite this and then sub in the answer from part 1 for the second integral. This is what we have. Okay, so 1 minus cosine 2 times of 2mx, henceforth we got that. Now we have not integrated yet, so make sure the integral sign still remains. And then for the other one, this is what we have. You replace the entire integral with your answer here. Notice that the plus c is not required because this is a definite integral with limits. If you put the plus c in, they're going to cancel out, right? So might as well, there's no need for you to write it. Okay, what we do now is suggest to simplify further the expressions here before integrating, whereas for this one here, you can start to sub in your limits. And with a bit more of a simplifying, right, this is what we have. Okay, do you realize that we kind of need some information about what sine 2n plus 2n times of pi is? What is this? And then when I replace x with 0, what is sine 0? Okay, sine 0, not difficult to use your calculator to check that actually this returns you 0. So then the entire expression there is actually 0. But what about here? We're looking at 2n plus 2n times of pi and 2n minus 2n times of pi. So this taps on your understanding about multiples of pi. So what is sine? Actually k times of pi, where your k must be an integer. Now, reason being that in front, it says that m and n are integers, so 2 times of n plus 2 times of n will be an integer, likewise for 2n minus 2n. So what can we say about sine multiples of pi, where the k is actually an integer? This will actually gives you the value of 0. So how to know that? You can either check your calculator sine pi, sine 2 pi, sine 3 pi, what are the values? Alternatively, you can follow the graphical sense. So just a quick glance of what the graphical sense is. Let me share with you. Alright, right over here. Okay, so you can sketch the graph of sine, and this is actually the graph of sine that we have here. Do you notice that at what we call multiples of pi, where it's integer multiples of pi, actually the outcome for the y is actually 0. Okay, we'll talk more about the cosine later on, right? So what we do is we realize that because this is actually will then be equal to 0, this is equal to 0, we can now simplify the first integral further, and then this will give me the outcome of minus 0. Or actually, you need not write that. Okay, so what we do next is we then integrate the expressions in front, and thereafter sub in your limits once again. Now, integrate the expressions in front, they are all integrable now, and henceforth we can sub in the limits thereafter, and back to the same concept of what is sine k times of pi. This will then be 0, this will then be 0. As a result, your answer is just pi. Okay, so this is for the question. Now, what if we have actually cosine and multiples of pi? What will then be the outcome? Now, in that case, it will depend on whether or not the k here, the integer here, whether it's an even number or even integer or an odd integer. So you can refer back to the graph for cosine of k pi. Alright, so you can sketch the graph. So the idea here is you can sketch the curve for y equals to cosine k times of pi, or you can sketch cosine graphs, and then you observe what will happen. So you should sketch cosine x graph and observe what happens at integers, cosine of integers of pi. All right, integer multiples of pi. Another one that's similar to the behavior of this is actually -1 to the power of n, because it depends on what n is. If n is an even integer, the outcome is 1 because that -1 squared, -1 to the power of 4. If n is an odd integer, it will result in -1. Okay, so this is just for you to take note of.